This video introduces a novel forward osmosis combined membrane system for desalination. Multi-stage flash and multi-effect distillation have been traditionally used in the desalination system. However, corrosion, fouling, and water quality problem are the general disadvantages of this process. Reverse osmosis is also used in the desalination system. However, the reverse osmosis needs high-pressure pump to produce the water. The high-pressure system causes problems like frequent maintenance work and fouling in the membrane. Recently, the forward osmosis is growing up as the optimal technology in desalination applications. Unlike the reverse osmosis, forward osmosis is an osmotically driven process which does not require the high-pressure pump to permeate the water through the membrane. The water flows naturally from the feed solution to the draw solution due to the concentration difference between the sections. Generally, in forward osmosis system, the water flux decreases because the draw solution is diluted along with the water flowing into the draw solution. Moreover, this process demands an additional system to regenerate the draw solution. Now, the forward osmosis combined membrane system created by Bennett M enables efficient water production for desalination and water recovery. The combined membrane consists of forward osmosis and pervaporation within one module. There are three separate flow channels inside the module, separating the feed solution, draw solution, and permeate section. When the water passes from the feed solution to the draw solution, the water product is simultaneously removed from the draw solution through the pervaporation membrane. Therefore, the draw solution is not diluted by the water flowing through the forward osmosis membrane. For that reason, the water flux through the forward osmosis membrane can be maintained at the high rate. Forward osmosis combined membrane system does not require the additional system to recover the draw solution, because the regeneration function is built in the one module. And the pervaporation is operating under the vacuum condition so that the water vaporizes at below 90 degrees Celsius. Consequently, the low-temperature waste heat or the conventional solar heat recovery system can be utilized to produce the high-purity water. Water recovery from wastewater is also important, particularly for the chemical and petrochemical plants. The water can be obtained as the product and the valuable chemicals can be recovered to minimize the chemical loss. When this technology is connected to a desalination process, the heat can be recovered from the overhead vapor of the distillation column. For more beneficial ideas to improve your distillation and water recovery processes, please do not hesitate to contact Bennett M.